All right, so thanks for coming to today's lecture. And just double check, so can anyone hear my sound and also see my share screen, which is about quiz 1?
Yes.
Yes.
Okay, cool. Oh, good. Thank you very much. Several things before we start. The first thing is the quiz 1, the marking for quiz 1 is done already, and I think you can see your marks on the UTS Online. Then if you have some issues about the marking, then please do contact me and Marlene together. Because this time in this semester, so Marlene helps to do the marking. So previously it's all done by me, but this semester Marlene helps on the marking. So if you have the questions about marking, then please do let us know. Oh, the marks are hidden. Okay, I'm going to make it unhid after the lecture, right? So double check with the marks. Then if you find some issues, then please do contact us. All right. So that's the first thing. The second thing is about the drop-in sessions for the hand activities about different sessions. So I've sent an email to you already. And first, I'd like to say why we are arranging this is to maximize your learning experience, because one of the most important part in this subject is about to know different senses and know how to use them and what kind of data you can get. So previously, without this coronavirus situation, then we will have different hand-on activities on different days that with different senses when we learn that. But because of that, in last semester we didn't have any chance to work on the real senses. But in this semester, we try to do that. But there are still lots of limitations on that. The first thing is about the health issues, right? So the health issue is our first priority. The safety is our first priority. So we want to make it safe, even we want to move it back. All right, and also the lab they located to us has a limited number of access. So the room has only 12 student access for each of the time, instead of a lot, right? But so what we want to do is we want you to fill the form that I send you to say if you want to do that or not. All right, and again, so this session is not compulsory. So which means if you don't want to join, or if you cannot join, that's totally fine. So if you are not currently in Sydney, then you don't have to join. And if you even if you are in Sydney, but if you don't want to join that section because you may be afraid about the safety issues, then feel free not joining. But we want to know your opinion. So who wants to go to the drop-in session for working on real sensors or not? So we need to know the number, and also with the limited capacity of the lab room, then we can manage about how to do that. All right, I think I got some questions. Ideally, we are thinking about doing the live stream. Then I need to confirm with Marlene if it's possible or not, but definitely we will have it recorded. All right, so let me confirm with Marlene if we can do the live streaming, and if we can do that, that would be great. All right. Okay, so that's about that session. So I request you to send the form back to me before 11 o'clock today, right? So if you haven't finished that, please do please do send it back to me. Then we can arrange of a drop-in session. All right. So again, that drop-in session is not compulsory. So you have the right to choose come or not to come. All right. So it is only for that if you want to maximize your learning experience and you want to work on with real senses, then we have this option that for you. All right. And okay, and if you choose to come, we will try our best to keep the safety. So for example, we will have hand sanitizer, then you can, every time you can clean your hands, and then we also do the sterilizing for the sensors, then you can pass it to the others, right? And also you need to keep the social distancing during that time as well. So we need to keep the social distancing as well. And what else? Okay, so we plan to make that drop-in session on the coming Monday, which means the next lecture and tutorial time. All right. So we will try to make a live stream, but if we can't do that, we will definitely make a record. Then the video will be online, will be available online. All right. So which means in the next lecture, if we confirm that we are doing this drop-in session next week, then it will be the same time during the lecture and tutorial time, and which means we will not having the lecture and tutorial at that time. All right, so you will either watch the live streaming, or you can watch the video record we did in the last semester during that time if you are not coming today. All right, so that's the thing for the drop-in session and for the hand activities with different sensors. So in the session, we try to let you to use RGB camera and RGBD camera, and also the laser sensor, right? And also we try to make it on one day, but the thing is, because the limited number of capacitors in the room, so we need to arrange it with your feedback. All right, so please do finish the form and send it back to me. I think before the end of this lecture. All right, so try to do it. It's quite simple, just 3 very simple questions with your name and your student ID, then if you want to join or not. All right, so any questions about that drop-in session? Any questions about that? Yeah, wait a minute. Where's the form? I send it via the email. So it's an online form. I send it via the email. All right. So double check with your email, and also you can find it in the announcement as well. But I mean, I definitely send email about that. All right. So feel free to say not joining, because it's not compulsory. All right. And any other questions on that? All right. So if everything's good, then please wait for our arrangement on that, right? Okay. Cool. So another very quick thing is, I still find a lot of students, they join this Zoom, this lecture as a guest. So please log in the Zoom with your UTS. So I found another one. So with your UTS account. If you don't know how to do that, just search UTS Zoom login. Then you will know how to log in with your log in Zoom with your UKS account. Then every time you don't have to wait for me to let you to get you into this room. All right, and then another thing we are talking about is quiz 1. So I promised to give you a reflection on that, right? So in quiz 1, I think most of you did a very good job, and you will know the marks a bit later. So in quiz 1, we have 2 questions. The first one is the camera calibration, right? This is quite important. I mentioned it a couple of times because if you want to do a project with engineering project or mechatronics project by using a camera, then you may buy a camera, but after that you need to do the calibration of the camera. Then you know what's the intrinsic parameters, including focal length and principal point, and also the distortions. But I didn't mention too much on distortions in the lecture. So those are the things we call it intrinsic, which means theoretically those are not changing during the use of the camera, right? And what you can do is you can do this calibration before you apply the camera in your project. Then you have these numbers, then you can use the numbers as constant in your further work, right? And that is quite important. And also, as I mentioned it to you, because you are using the intrinsic parameters as constant in your further work, then which means the accuracy is quite important. Right, so that's why here I was asking you to do the camera calibration, and together I need you to analysis on the accuracy to make sure you finish the camera calibration and the result you get is accurate. All right, so that's the first question. And the second question is to use the intrinsic parameters you have to project a point, onto the image and know where the projection is, right? This is about using the camera calibration, right? So which means suppose you have a camera and you want to use it later, all right? So the first thing is you do the camera calibration, and then you may use it to calculate this projection. Then you will know if the error you got in the camera calibration is quite large, then which means you will get a different projection number, right? Because you're using the intrinsic parameters as constant, right? So different calibration results will resulting in different projection locations you calculate it. So which means the calibration accuracy is quite important, right? And also this projection is very important as well, because if you want to use the camera and you want to use the geometry information you got from the camera, and the camera projection is the fundamental things you need to know. You know that, and you will definitely use it later in the visual serving and a lot of things else. All right, so let's come to some reflections on what you did in the quiz 1. Again, as I mentioned, the accuracy of the calibration is very, very important. So do make sure your calibration result is accurate. All right, so you need to know if the result is accurate or not. There are a lot of intuitive way to know if it's accurate or not. But I'm going to mention some intuitive way, and also I'm going to mention the ways which is theoretically correct. All right, so one of the intuitive way is during your calibration, you will have fx, fy, and px and py, right? Fx, fy are the focal lengths, and px and py are the location of the principal point, right? So ideally, fx will be equal to fy. Because you only have, there will be another question. I'm talking about it a little bit later, but what I mentioned is here. So for one fixed length, it only has one focal length, right? It only has one length of the focal length, right? But why we have two here is because this focal length is in the metric of the pixels. So which means if you have a calibration result with focal length as 800, then which means it's not 800 millimeters, but it is 800 in pixels. All right. So fx means the focal length in pixels, but in the x direction, in the size of the pixel on the x direction. And fy is the pixels in the y direction. So which means in your sensor, so most of the cases in the sensor, for each of the pixel is not ideally square. It will have a little bit difference between the size of x and y. Then that's why you have a different fx and fy. For focal length, it's only one number, but it is in pixels. And the pixel size for x direction and y direction will be slightly different. Then that's why it makes a little bit different between fx and fy. All right, so that is one thing. And if ideally the size of the pixel will not too far away from square. Then which means normally what you get for fx and fy will not be too much difference. All right, so they will be very close to each other. Then if your result has an fx which is quite different from your fy, which means normally is you have not correct or not accurate result. All right, so that is one way. And the other intuitive way is about the principal point. As we know, ideally, when we manufacturing the camera with the lens, so we want the principal point, which as close as possible to the image center. For example, if you have a 640 by 480 image size, then ideally the focal length will be, the principal point will be quite close to the image center, which is 320, what is that? 320 by 240, right? Right, will be quite close to that. So if you find your principal point is quite far away, from the center, then probably you get a wrong or not accurate calibration. But I should say it will never be the center, because your manufacturing of the camera will not be that perfect. It will not be the center, but it will not too far away from the center. All right, so that is another intuitive way. But what I want to introduce is it's a proper way about checking the accuracy. Right, the first one is the variance or the covariance they provided, or standard deviation it provided. Right, so after you do the calibration, you have a result. Right, focal length, principal point, and also the distortion parameters. Then after that, there will be a standard deviation on that. And if the standard deviation is quite large, then which means your accuracy is not that good. All right, so that's the first one. The second one is from the calibration problem itself. So the calibration problem, I'm not quite sure if Malin mentioned that to you or not. So it formulates the calibration problem as an optimization problem. All right, and the objective of the optimization is try to minimize. Wait a minute. is try to minimize the location of the corner you extracted and this corner location that you recalculated in the optimization, right? So which means the objective of this calibration, camera calibration, is about to minimize the UV differences, the differences of the points on the image, right? So which means after the calibration, they will report to you about this objective, and which means what's the reprojection error. So it will tell you it's about 1 pixel, 2 pixel, or 10 pixel, or 20 pixel. It will tell you about that, right? And also you can plot those reprojection errors onto the image as well. So if the reprojection error is quite small, then which means you have a better accuracy from of the estimate from the optimization problem, right? So that is another theoretical way about telling you if it's accurate or not, right? I found most of the cases is about the calibration result is not that accurate. It's not that accurate. It quite obviously can see from the result. But what I mean is you can check it. You can check the accuracy in an intuitive way, and also in a theoretical way. All right. And normally, because the corner extraction is from what we proposed, sorry, what we've done for giving the corners of the maximum size of the block, right, of the block. So if the camera has a lot of distortions, then which means even you provide the 4 corners of the checkboard, then the corner extraction inside it will not be that accurate. Then that's why we need to do a recalibration. So if you've done everything correct, you will definitely find, if you do a recalibration, the reprojection error will definitely reduce. That's why we need to do a recalibration. The recalibration means there's the recalibration means in your first calibration, they will calculate for each of the corner the 3D location of it, right? And based on that, if you do a recalibration, they will reproject those 3D points onto the checkboard, and then do another cross like corner detection. And that corner detection will give you a much more accurate one. All right. So that's why doing a recalibration is quite important. If you definitely reduced the error onto the calibration. All right. And another thing is, this is what I want to test you in quiz 1. And I do think you will have the case in your future work. So for example, in this picture, if you can see it in this picture, even we have a very large checkboard, very well printed checkboard, then we can see for lots of images, it cannot include the full checkboard in it, right? What we can do here, so if for some of the images, you choose the outer 4 corners of the full size of the checkboard, but in some other images, you can't choose those 4 points. Then which means it will bring you some issue, it will bring you some error on it, because for the calibration, you need to point out the 4 corners, and they will form a frame of that, of the coordinate frame of the checkboard. But if the coordinate frame changed, they will bring the issue or the error on it. right? So in this case, what we can do, it is quite simple. The first thing is you go through all the images, and to see the maximum area, for the maximum area that all the images can observe, right? And then you just use that area as the one you want to use, which means you don't have to point out the corners of the complete checkboard. What you need to do is, suppose in this case, we can use the side, you can use the checkboard, which is one block inner to the full size, right? Then for every image, we point out the 4 corners as that. And then you still can do this calibration, right? But there are some intuitive ways. Very easy ways is that you just delete the images that you they can't observe the 4 block, the 4 checkboard. But the thing is, when you delete the images, when you delete too many images, then it will reduce a lot of information from it. If you want to include all the information to your calibration to make it as a better accuracy, then you can do something as what I proposed here. And this is what I really did in my work. All right, so that is one thing. And another thing which is quite tiny is, I think I give you PNG. I can't really remember the format of the images, but for the camera calibration toolbox, they can't read, they didn't support the format of that images. And that is quite easy. You just convert the image into the format that you can read it from the calibration toolbox. All right, and I think a lot of students is asking about the block size, And can anyone tell me why I didn't tell you? Can anyone tell me why? Okay, so let me give you an answer. So if you only want to do the calibration with the intrinsic parameters, if you only want to get the intrinsic parameters from the camera calibration, then the actual size of the block, it doesn't matter. But the thing is, it has to be the square. It has to be square. Otherwise, it will be different. It has to be square. But if the checkboard, if the blocks in checkboard they are square, then if you only want to calculate the intrinsic parameters, then the actual size of the block, it doesn't matter. Can anyone tell me why? Can anyone tell me why? Sorry. The reason is, if you come back to what you have, in the calibration, you have focal length, you have principal point, right? So what's the metric for the principal point? Suppose you have 320 and 240. That's in pixels, right? That's in pixels. And what's the metric for the focal length? Suppose you have 800 for focal length. It's also in pixels. So you get everything in pixels, which means everything is not with respect to the actual size. What you get are all relative. They're relative to the size of the pixels. So you have focal length fx, suppose is equal to 800, that is in pixels. You have fy is 810, that is in pixel as well. Right, so you have your principal point, which is 320 and 320, 240. They are also in pixels. So everything is relative, and nothing related to the real size. That's why I said I can tell you the block is square, but I'm not going to tell you the size. And that's the reason. So you can try it after the class that you do this same calibration, but with the input of different block size. And for the intrinsic parameters, they will give you roughly the same thing. Because it's numerical calculating things in the optimization. So I can't promise to give you exactly the same, but it will be roughly the same, right? Then let me ask you another question. If we put the actual size of the block, then what we can get to the real size. So what are the things we can get in the real size? Why we are putting that? Why we are putting the numbers, the real size of the block in it? So what kind of like other things we can get, which is in real size? Sorry, can anyone tell me? Think about that. It's a very good question, right? All right. So what we can get in actual size if we give the actual size of the block is the intrinsic parameters and also the 3D locations of the points. So after you do the calibration, you can find you're not only getting the sorry, wait a minute. You are not only getting the intrinsic parameters of the camera. You can also get the extrinsic parameters of the camera, which means the camera poses with respect to the coordinate frame of the trackball, right? And you can also get the estimate of the 3D locations of each of the corner you extracted. And for both of them, they have scale in it. If you give the actual size of the trackball, of the block in the trackball, then you will get the extra pose and locations for that, right? But if you didn't give an actual size, you still get the extrinsic parameters, which is camera poses, and also the 3D locations of the corners. But they are up to one scale you give to the real world. You're up to a scale to the real world together. Totally, they're up to one scale to the real world because you didn't give the calibration with an extra like block size. So is that clear? Is that clear? Any questions on that? Okay, seems good. All right. So let me ask you another question. If you want to calibrate a stereo camera, so which is two cameras together, if you want to calibrate a stereo camera, does the real block size matter or not? Do you have to provide the actual block size for calibrating a stereo camera? Try to think about the question and give me your answer. Yeah, I got an answer saying yes. Can you explain about it? Why? Yeah, I think that's a near correct answer. Near correct answer. So why we need the answer is definitely yes. So if you are calibrating a stereo camera, then we'll definitely provide the actual size of the block. You definitely need to do that. And why? So follow my questions and think about that. So why we are using stereo camera? because we can recover the depths, right? We can recover the depths from the stereo camera. And why is about that? Why we can recover the depths is because we have a baseline. We have two cameras together, and we have a baseline between the camera. And that baseline is fixed as well, right? So if you have a stereo camera and the baseline is fixed. And during the calibration for the stereo cameras, one of the intrinsic parameter is the baseline. And can anyone tell me the baseline has scale or not? The answer is yes, right? So the baseline contains scale. If you can make it as if you want to make it as a relative scale, then the distance, the depth you recovered from the triangulation is with a relative scale as well. But if we know the actual size of the block on the checkboard, then we can calculate the baseline with a real scale. Then which means when you use the stereo camera with the baseline you calculated, the depth is in real scale as well. So that's why in the stereo cameras, when we want to do the calibration, we need to provide the actual size of the block on the checkboard. Is that clear? Is that clear? All right, cool. So let me do something. Let me try to conclude it. So if you want to do a camera calibration, single camera calibration, which you only want to use, you only want to get the intrinsic parameters, which means focal length, principal point, and also the distortion parameters. Then, which means they are all in the relative scales. They're all in relative scales. Then, which means you don't have to provide the actual size of the block. But if you want to use the extrinsic parameters during the camera calibration, for example, if you want to use the camera pose from the calibration, then you need to provide the actual size because the camera pose is also in a relative scale if you don't provide the actual size. All right. And if you want to do a camera calibration for the stereo camera, then you definitely need the actual size of the block because you also want to calculate the baseline between the two cameras. And that baseline is with scale. So you have to provide the actual size of the block, then you know the actual scale of the baseline. All right, is that clear? All right, cool. So if all good, let's move to the second question. It's a bit slow, right? But I think there's a lot of information in it, right? So hope you'll be happy if I'm discussing this. And the second question is quite straightforward. You just need to project a 3D point with the intrinsic parameters you get from the calibration. And I found some issues or some of the things during your quiz one, but some of them I didn't reduce any mark on that. So the first one is you have fx and fy instead of one single focal length number f, right? Why we have that, I think I've explained it already. And now is how can we use it? How can we use it in the calculation, right? So there are two formulations. If you remember. One is the matrix format, and the other is the just equation format. All right. So if you use it in the first one, which is the which do not contain any matrices, then if you have two numbers, I saw some of the students, they just give an average on the fx and fy and use a single f number in it. Theoretically, it's not sound, but I didn't reduce any of the marks, but still, theoretically, it's not sound. as I mentioned, the fx and fy, why they have two numbers is because they are relative. They have relative scales. They are fx and fy in the pixels, and in the x direction of the size of the pixel, and y direction of the size of the pixel. Then I think it's quite obvious about how to use it, right? So when you calculate u, which is the x coordinate of the 2D point on the image, when you calculate the u, you use fx. When you calculate v, you use fy. All right, is that clear? Is that clear? Okay, cool. So if you want to use the matrix formulation, then what you can do is, if you remember, there is the camera calibration matrix. We call it a K, right, which is a 3 by 3 one. And on the diagonal is F, F, and 1, right? And on the last column is PX and PY, and also the last one is 1, right? And if you have fx and fy, it is quite easy. So for the diagonal elements, the first f, you put fx on it. The second f is fy. And the last one is 1, it's still the 1. And then if you modify your calibration matrix like that, and it will provide you the correct answer. Are there any questions about how to use fx and fy? Okay, good, all good. So another thing is about the coordinate frame of the 3D point. I didn't find any of the issues during the quiz one, because I give you the simplest case, right? So the simple case is the 3D point is in the camera coordinate frame. Then what you need to do is you just need to use the central projection with the principal point offset, right? You just need to use the central projection with the principal point offset, because your 3D point is in the camera coordinate frame, right? All right, so that's the simplest case. But if in the future, for example, in quiz 2 or in the final exam, I'm also giving you the question about the camera projection, but I give you a point which is in the global coordinate frame, which is different from the camera coordinate frame. Then you need to know how to do that as well. That's a general case. I mentioned that already in the lectures. Then you need to know how to do that as well. All right. So what I mean here is, suppose in the future you have questions about this camera projection. Then the first thing you need to check is what's the coordinate frame of that 3D point. Then you will choose different formulas, different equations to calculate it. All right. Is that clear? Right, so if in the future you have similar questions about camera projection, the first thing you need to check is what's the coordinate frame of the 3D point. All right. Okay, so another thing is I found some of the students, they use the initialization of the camera calibration as the input to calculate the projections. So if you can, when you do the calibration, because it is a nonlinear optimization problem, which means it will provide an initial guess. We call it initial guess for the parameters you want to calculate it, and put it in optimization, and finally give you the result, right? You need to use the result as the intrinsic parameters in your future work, but not the initialization. The initialization is just initial guess. It's not the actual estimate you want to get. right? It's just the initial guess of the optimization problem. But what you want to use in your future work, in the further work, are the estimates from the optimization problem, but not the initial guess. All right, so that is all the issues I found during the quiz one. So is there any other questions about quiz one? Yeah, I think I got one. Yeah, I mentioned that. I'm not quite sure if you hear that or not. So after this lecture, I will release the mark. All right. After this lecture, I will release the mark, and please do check on the mark to see if we've done something wrong, and if so, please do send us an email. Send an email to both me and Marlene. All right, then we can double check with the marking. All right. Yeah, I think when Marlene did this marking, he has already provide some of the comments on that already. So when you have the marks, then if you find something wrong, so please do let us know. All right. So any other questions? Any other questions about the quiz one? All right. So if everything's good, let's move a little bit forward. All right. So before we move forward, let me say it again. So next time, please log in the Zoom with your UTS account. Then every time you join this meeting, you join the lecture, you don't have to wait my permission to let you in, right? Because I just got a lot of joining in with waiting for my admit just now. So please log in with your UTS account. Then when you join in, you don't have to wait for my admit. All right, and why the university is doing that is because they want to limit the person who are joining in with different subjects. They don't want the students from somewhere else to join in. All right, so please do log in, and then next time when you join in this Zoom, then you don't have to wait for my permission. All right, so the next thing is about the group project. Wait a minute. Okay, so the next one, thanks, Frank. All right, so the next thing is about the group project. Can anyone see the Word document? Everything's good? Can you see the Word document about the group project?
Yeah.
Okay. Oh, good. Oh, good. Thanks. So again, so the group project is half of the weight of the marks in this subject, which is a lot. So it's changed from the last semester because of the current situation. So we can't make the marks over 30% of the final exam, and so that's why we moved it here. And this is also what I want to do, because for my point of view, the learning objectives is that you have the ability to choose the right sensors and the right control method and apply it onto the real project, the real case on the robot or mechatronic systems. then you can solve a very simple but proper problem, right? So this is also what we aim for. So the project weight a lot, which is 50%. So I do suggest you to perform well during the this group project. It's 50%. It is a lot, and there are lots of deliverables during it. So I'm going to introduce it a little bit later. But what I mean is, I do suggest you to perform well during the group project, and not only because it's 50%, but also I think it's the most fun part in this subject during the last couple of semesters. You will find a lot of fun on it. You will find you are solving the real problem with real robots, and you will find you can manage to solve an engineering project, all right, and to collaborate with your team members together, and finally you work it out, and you can demo your work to the others, which is a very exciting thing. All right, so that is 50%, again 50%, and I do suggest you to form a group of 3 students, All right, so you need to form the group by yourself. So contact with the students, with classmates, and then form your groups with 3 students. And every work is done in groups. But some of the deliverables, they are individual, but the main work is formed in groups. And also because of the current situation, you can also form your group in 2 students, or even you want to do it by yourself. Previously, I do suggest to do that, but in the current situation, if you have some difficulties to form a group, then you can do it with 2 students, or you can do it by yourself. But the thing is, the task is there. I can't change the task based on the number of the members in a group. So which means if you choose to do the project by yourself, or if you want to choose to do the project by 2 members in a group, then you still have to finish the project, the task in the project, right? So try to think about that. But I mean, I'm not forcing you to have 3 students in a group, but it's better to do that because I'm not going to change the tasks in each of the projects you choose. All right. So there are some schedules. So today I'm releasing the project list. And then I will explain the projects one by one to you. Then you have a better feeling or understanding about projects. And during that, if you have questions, you can ask it to me, and then I will explain it to you. Right. So today I'm going to introduce the projects in the list one by one, and then after that, you have a week to choose the projects that you prefer to do. All right. So you need to choose at least 2 projects from the list, and with the order that you preferred, and you post what you choose in the on the discussion board with the topic here. So I create one. So if you can see the website, so that's the discussion board, and then there is a topic here, is 2020 Sprint Group Project Selection. So post your selection of the projects together with the team number here. All right. So as what has said, you need to choose at least 2 projects. Better to be 3, but at least 2 projects with the order that you preferred. For example, if you want to do the Fetch Robot project first, and the Turtlebot project second, and you list the project with that order. Then after all the students has formed the team and also have their preferred projects, then I'm going to allocate the project to you. I can't promise what you I can't promise what the project I allocated is your first choice, because I need to balance the choice of the different projects. Right? It will be not good if all the students are doing Turtlebox project but with nothing else. Right? So I'm trying to balance the project you choose. So which means I can't promise you to locate you the first project you choose. I'm trying to locate you the project with the order that you have. All right. So the thing is, after today, you need to first form the group of 3 students and choose the projects that you want to do. And at least you need to choose 2 from the list. And then I will, before next Monday, I will allocate you the actual project you're going to do. All right. So the deadline for forming the group and also submitting your choice of the projects is this Sunday by 6 p.m. This Sunday by 6 p.m. All right. So if you have a better suggestion on the project, which is different from what we have on the list, I'm quite happy if you're doing that. But the thing is, if you want to do that, you need to write the title of your project, and also you need to write a brief introduction about the project, also with your deliverables, tasks and deliverables. Send an email to me, and I will confirm with you that if the tasks and deliverables are enough for the project, for the group project that we want to do in this subject, then you can do that what you proposed. I'm quite open with that, but the thing is, you need to confirm, you need to write what you want to do with clear deliverables and tasks. Then I can have a feeling about if that project is enough for this subject. All right. So that's the first thing we need to do. Form the groups and post what you choose. And then I will allocate you the actual project you are going to do. All right, so that's the first thing. And the second thing is about a proposal. So why we are going to do that is if you go through all the deliverables and what we are going to do in the project, it's really about what we really do a engineering or robotics project. So if in the future you are doing a project, engineering project or mechatronics project or robotics project, or even some other projects, it's mainly about what we organized here. So at the beginning, you will have a topic, and then after that, you need to give a proposal. And after the proposal, you will have a mid-review, and you will also have the presentation in your final review, and also you need to write a report of that. Also, sometimes you need to submit the code and some other things to your customer, something like that, right? So what we organized here about the group project is what you may really need to do in your future. And this is what we are doing in all of our projects. And this is also a training to you that if in the future you have this kind of project, engineering project, and what you're going to do. All right. So about the proposal. What is a proposal? A proposal is if you are located, or if your customer wants you to do a project. So you need to do some analysis on that project, which includes, and also you want to make that project in a little bit details, but I'm not aiming for a very detailed one, because you haven't done it yet. You don't know what exactly details about methodology or something or experiments in it. But before you do that, you need to have very careful thinking about that project, right? For example, what's the scope in it, and what's the deliverables in it, right? So what's the methodologies or the approaches you are going to apply in this in solving that project, right? It may be different from what you actually used, but at the beginning you need to have an idea about roughly what kind of methodology, what kind of approaches that you are going to do, right? And also you need to do some literature review and find out what others done and what kind of method you can borrow it into your project, right? So that is the proposal. The proposal helps you to have a better understanding and also have a careful thinking before you do the project. And also very important is, if you remember in the first lecture, I'm asking you about a moving robot which can pick up something on the table, and I'm asking what are the problems involved, and for each of the problems, what kind of sensors and methods you're going to use. So this is similar. So if you have a project already, then you need to divide it into different small tasks, right? And also because you have a team, then you need to give a plan. Better to have a plan prior to really doing that which member is doing which task, something like that, which is also a very important part in the proposal, which is about the project management. All right, so that is the first proposal. So first deliverable, which is the proposal of the project. And you need to submit this deliverable per group. I mean per group, which means each group only needs to submit one proposal. All right, and the deadline is 1 week after that deadline, so which is the August 30th, 6 p.m. All right, so 1 week after you choose the project, then you need to submit your proposal. You don't have to make it very, very detailed. So I want you to limit it within 5 pages, but don't make it quite simple. Again, don't make it quite simple. I saw a lot of submissions in the last couple of semesters that they only have 1 page or even less than 1 page or 1.5 pages. Why you have that is because you don't have a careful thinking about your project. I do believe after you have a careful thinking on that, your proposal will not be that brief, because there are a lot of things you need to think about. You need to arrange, and you need to do some literature review before you do that project. And those kind of things, I don't think it will be only 1 page or 1.5. All right. And why I mentioned that is also because from last semester, we have different deliverables. And different deliverables, they will have different marks. So for example, for the proposal, it's 5%. It's 5%, which is 5 marks in your total marks. All right, then which means even you do a very perfect project at last, but in this deliverable, you didn't do it well, or even you didn't submit any proposal, then the maximum mark you can get is 45 instead of 50, because we have different deliverables. So what I want to say is, in the last semester, well, we have a lot of cases that they've done a very good project at last, but they didn't do it carefully on the previous deliverables. Then they can't get very good marks on different deliverables, and which means at last the reflection on the marks will not be that high, because even you've done a perfect project, but you didn't do a very good deliverable on maybe on proposal on the mid-review report, then I can't give the marks, give a high mark on those two deliverables. Right. So what I mean is try to make every deliverable well, instead of making a very good. I mean, definitely better to make it good. You make your project good, but I mean, deal with different deliverables carefully as well, because they have marks for different deliverables. All right. So that is the proposal. It is per group, and it is 5%. All right, and I also want to say something about if you are requiring to submit something per group instead of per student. So, for example, for the proposal, even if it is submitted per group, which means for each of the group you only need to submit one document. But I'm requiring you to mention the contribution, individual contributions. I mentioned it here. Individual contributions here. For example, you have student 1, 2, 3. For student 1, it has 30% contribution on that, on the proposal. And for student 2, you have 30%, and student 3, you have 40%. So you need to mention that. Then I will give the mark also based on the individual contribution on a per group submission. All right, so that is the first deliverable, which is the proposal, 5%. And the second deliverable is the mid-review report. The deadline is 3 weeks after you submit the proposal. The deadline is the 3 weeks after you submit the proposal. All right, and this mid-review report is submitting per student, again per student. For example, if you have 3 students in your group, I'm going to get 3 reports individually about mid-review. All right, and the mid-review mainly includes the what you've done until the deadline. You just need to write what you've done until the deadline. And what you need to write, because it's submitting per student, you only need to write what you've done by yourself instead of the others. All right, so for example, if in your project, you are doing fetch robots grasping, right? And student 1 is working on the object recognition. The second is about control of the robot arm. And the third one is about integration, something like that. And what you need to write here is only about what you've done, not the others. All right. And also I need to mention, because we have experience in the last semester. So I got a lot of students, they didn't do anything until the deadline of the mid-review report. But after three weeks, they've done a very good job in the group project. I don't suggest you to do that because this deliverable, there is a mark. I can't give the mark of your mid-review report based on your final project, right? So which means if you do that, you will have a very good mark in the following deliverables, but you will not have a good mark on the mid-review report deliverable. I don't suggest you to do that. It's 5%, so try to manage your project in a long period instead of like doing your project within the last 2 weeks. Because if you're doing that, you don't have too much things to write in your mid-review report. Then you will not have a good mark on that deliverable, right? So try to manage your project with a good timing instead of like put everything at last. Because if you're doing that, you will lose lots of marks on the mid-review report deliverable. All right, is that clear? this is what I got. This is what I got in the last semester. So I have a lot of like groups that they've done very, very good projects at last, but because they didn't do too much things in the first three weeks, then they lose some marks on that. So the final marks may not be that high, right? So this is what I want to mention here. And after that, you have another 3 weeks to work on the project itself. All right, and the next 2 deliverables are first one, the code, and second, the video demonstration. And that is 3 weeks after the meet review report. Right, so that is 3 weeks after the meet review report and 1 week before the presentation. 1 week before the presentation. All right, so there are 2 deliverables at that time. One is the code. So you need to submit a code. You need to submit the code you used in the project because it's 1 week before the presentation. I'm supposing you finish everything already. All right, so you need to submit the code, and together with the description about code, right? So what's the code include, and what's the different part means. You need to get a brief introduction or explanation about that, and also you need to give a README that I can run your code from my side. Then I will test every of the code, then to give you the mark. All right, and also because it is a per group submission, so which means for each of the group you only need to submit 1 code, then I can run. Then which means you need to also write the individual contribution of the coding. You need to write the individual contribution about the code in your description. All right, and another deliverable is about the video. It's still submitting per group. So each group only submitting 1. And that video will include the demonstration of your work. All right, so suppose you are doing a Turtlebot project on the simulator, on the robot simulator, and you need to log a video that to demo your work really works. Your project really works. Or if you are working on a real robot project, a real Doobot project, then you need to log a video. You can log the video with your phone or something. Log a video that your project really works. All right, so that is the deliverable of the video. So the code is 10%, the video is 5%. All right, and again, because the video deliverable is also per group, so which means you need to write a README document, very brief one is fine, to explain about the video and also including the individual contribution of it. All right, so if you think it's a little bit hard for you to write the individual contributions in this kind of document, you can send me a private email about talking about that. All right, if you prefer to do that, you can do that. I mean, if everything is fine, just write the individual contribution in the README file. All right, so that is 1 week from the presentation day. And on the very last lecture of our subject, we will have our presentation day. We call it project teaser presentation. Sorry, that is 10%. That is 10%, and it is per group. So which means on the presentation day, so which is the very last lecture of our subject, then we will have the presentations for all the groups about their project. So you need to present your work about your project within 5 minutes. Within 5 minutes, you can prepare a slice or some other things during the presentation. So any way is fine to me. But the thing is, try to use that 5 minutes to impress the others, then you will have the others will have a better understanding about what you've done, and they will evaluate if your work is good or not. That is about the presentation. The time is very short, and it happened in a lot of very good international conferences. It's because maybe the audience will not have enough time to listen to your presentation for about half an hour or 15 minutes. But the most attractive time, or they have their attractions to your work, is about 5 minutes, very short time. So try to use a very short time to impress the others, to let them know what you've done, and to impress the others. And that's the audience to know, oh, your work is pretty good. Try to think about how to do that during the presentation. Then this is very important as well. For a lot of projects at last, you will submit a report and also you will do a presentation. If your presentation is horrible, which means you have a 30 minutes presentation, but the audience or your customers will only listen to you with 5 minutes, and the rest 25 minutes they will sleep. Then which means you didn't introduce your project well to your customers, to the audience, right? And the presentation always play a very important role in your project, because they may only have this kind of short time to understand what you've done. They may not read your report, your 100-page report carefully, but they will definitely listen to your presentation. So if you think about how to present your work in a very short time and impress the others, then it's a very good, very, very good way to sell your work to the others. That is quite important. And also, the marks of this presentation, we make it peer review, which means for all the students, they will give the mark of your presentation. All right, and the final mark, 10% final mark of this presentation is only based on the peer review result. All right, I'm not giving the mark to this. So your mark is only based on the peer review result. I have a form that, and before that, I'll send it to you. I will explain to you how to do it. But what I mean is, this presentation mark, 10%, is not given by me. It's given by the peer review result. All right, and you also need to submit the slides and the videos and everything related to your presentation to me prior to the presentation. All right, and that is 10%. And one day after is the deadline for the final report. And the final report is per student. It's per student. The final report means a complete result of the whole project, which is different from the mid-review report. What I mean here is, even it is written and submitted per student, so which means in each group, there are 3 final reports written or submitted by different team members. But for each of the final report is a complete report. So you will write in each of the report, you will write everything in the project, including the work done by the others. All right, but I do want you to simply copy and paste what the other team members write. You need to write it by yourself, but you need to write everything included in the project, including the methodologies used by the other team member, and also the experimental results you have. Maybe you're not doing on that, but you need to write it in. All right, so what I mean is, a final report is a complete report. It's not only including what you've done. It's a complete report of the project you've done in a group, but you need to submit it per student. All right, so why you may have questions why we have submissions per group and per student. It is because the rules at UTS. So we can't make 50% of the mark which are not including like individual works. Right? So if everything is per group, then it's not aligned with the rules, ETS rules. So we have to make some of the deliverables per student individually instead of in a group. But I think it is good. It is good for some of the works. We can clearly see what you've done for by individual team member. I think which is good as well. All right. So any questions about the deliverables or the management of the project? Any questions about that? Any questions about that? Yeah, I think I got one. This document is online. It's on the UTS Online Blackboard and assessment. I'm not quite sure if I still logged in. So if you can see my UTS Online, then there is assessment. I need to log in again. Assessments. If you click on assessments, and there is a sorry, let me change it to here. Sorry, and you can see the group project list spring 2020. Right. So the document is there. So it's exactly the same document. Okay. So if there's no any other questions, I'm going to introduce the project one by one. And if you have questions about each of the individual projects, you want to have more information, so just unmute yourself and ask me about questions, right? Okay, so okay, so group projects. So the first two group projects is about Fetch Robot. Right. All from the beginning, we in the previous semesters, we don't have this like social distancing situation. Then we have lots of projects with real robots. But in last semester, because of the situation, so we can't get access to the real robots. But this semester, we are trying our best that you have the options to choose the real robot to do. All right. So we've discussed a lot with the Mechatronics Studio. Then we have a solution. About with the real robots, how to do it with real robots. All right. So I'm going to introduce it inside the project. So which means in this semester, if you choose the project with real robots and you want to do it with real robot, and you can do that. But you also have the option that you only work on the robot simulator. All right, so both are fine. You have two options, both are fine. And then it's totally up to you what you want to do. But the good thing is you have for most of the projects, you have the option about working on the real robot. But I will let you know a little bit later about how we can organize this, because there's still like healthy safety issues that we need to obey to. All right. So you have two options for some of the projects. One is you're working on real robots, and the other is you're working on fully on the robot simulator, and that is totally fine. There will be previously there will be mark difference. So for example, if you work on the real robots and you can give the demo on the real robots, then you have a higher mark. But in this method, there will be no difference, because I know some of the students, they can't get access to the uni, or you may be concerned about the safety issues coming to the uni to work with real robots. So it's totally optional if you want to work on the real or not. And if you're choosing working on the robot simulator, there will be no marked difference comparing to like working on the real robots, right? So I think I'm explaining it clearly, right? Okay, cool. So the first two projects are about the fetch robot. And if you're working on fetch robot, and if you can work on the real robot, then you have the opportunity to represent CAS to demo your work in the future. For example, the UTS Open Day. Right? So we always have this option. So if your project doing really well and you have the opportunity to present us to demo your work during the UTS Open Day. And on that day, I think a lot of students, especially some future students coming to UTS, they will know about your work. All right. And again, for fetch robot, there are two options. One option is you've done your work fully in fetch robot simulator. So there is a very beautiful fetch simulator. Then you can do everything. You can test everything on the fetch simulator, which is nearly exactly the same as what you've done, what you've done on the real robot. So that's a very beautiful fetch robot simulator. You can work on that. And the other option is on a real fetch robot. But the thing is, if you're aiming for the real robot, you need to test everything on the fetch simulator first, because fetch is very expensive, very big, and also not it's a bit dangerous if you're not controlling it well. I don't want to see the robot will break you or break itself. So if you want to work on the real robot, first work on everything, make sure everything works fine in fetch simulator. Then I will locate one of my PhD students, or maybe Malin can help on the fetch robot things. You're moving your code to the real robot. So if you test your code, everything fine in a simulator, it's quite easy to move it to the real robot. All right. So that's the fetch robot project. And project one is fetch robot following the path. So what it means is, suppose you are the leader. And you're walking in front of the fetch. Then the fetch robot can follow you. So you can design everything you want. For example, if you want to simplify the problem, you can print a very huge QR code and tape it on the back of the person, of the leader. That's totally fine. And then you can use RGBD sensor or the laser on the bottom, or any sensor you want to make this task working. All right, but the task itself is make the fetch robot following the leader. And you can choose one of the team members as the leader to make the demonstration. Or you can make some simulations about what's the leading object in the simulator. All right. So on fetch robot, I think I should mention something. So on fetch robot, we have a 2D laser here, and we have a six-stop arm here, with a gripper there, and also we have an RGBD camera on the head. So this is what we have on the fetch robot. All right, so you can choose to use any of the sensors on the fetch robot to finish the task. All right, so that is the first project, which is about fetch robot following the past. And the other project, the project 2, is fetch robot grasping. Which means I think I've demoed something to you, right? So if you have a table and there are different objects on the table, and you need to control the robot arm to pick up the objects. And please don't hard code the grasping. So which means you need to use the sensor, maybe RGB or RGBD sensor, to detect the object, to recognize the object, and then estimate the pose, the location and the pose of the object, and control your robot arm to pick them up. All right, and in this project, you need to make at least 2 objects. For example, you're simulating a can of Coke and also a bag of chips on the table. And then in your method need to identify, for example, I'm asking the robot to pick up the can of Coke. And in your algorithm need to distinguish the 2 objects and tell the robot know which one is the can of the Coke and control the robot to pick up it. The more the better, but at least 2 objects. All right, so that is the second project, which is fetch robot grasping. And again, so if you are interested in some of the projects and you still find something is not clear, just simply stop me and ask the question, right? All right, okay, cool. So those 2 projects are the fetch robot projects. And the following 2 projects are about the DoBot project. And for DoBot project, you only have one option, which is working on real robot. All right, again, for DoBot project, you don't have the option about the robot simulator. If you choose the DoBot project, you need to work on the real robot. Otherwise, don't choose the DoBot project. All right, is that clear? So for DoBot project, there's only one real robot option. So there's no robot simulator option. So if you don't want to work on a real robot, don't choose DoBot project. All right. So the first DoBot project is about control and grasping for using the DoBot. It's similar to what we have in fetch robot, but it's in DoBot, which means there's only a sucking section on the end effector, and you can't pick up 2 heavy things in it. It must be tiny things. All right, so that is the first DoBot project, which is the DoBot grasping, and you can have a look. About the DoBot and just feel about it is difficult or not. All right, so the second project about DoBot is the hand-eye calibration for the DoBot. So if you don't know what is hand-eye calibration, please go to the visual serving lecture. Have a look at the visual serving lecture, and at the end, I provide what is hand-eye calibration. So for example, if you want to control the DoBot, and if you want to control the DoBot to do some task, and maybe you need to use some camera to do the visual serving. So you can put the camera on the end effector, on the robot, or you can put the camera on a fixed global location. But for both of them, you need a calibration. For example, if you put it on the end effector, so you need to calculate the relative pose between the camera and the end effector. Then when you control the camera, it's some kind of like you control the end effector. So that is hand-eye calibration. And you need to do the hand-eye calibration for the DoBot. All right, so have a look at the visual serving section of the subject. Have a look at the slides and the video, and you have a better feeling what is hand-eye calibration. All right, so that is for the DoBot. Then the fifth project is about 3D reconstruction of the RGBD camera and EM sensor, which means for the RGBD camera, you can get a 3D point cloud, but with the coordinate frame of the current camera position. Right? But if you move it, you still get the point cloud, but they are not in the same coordinate frame. And what we propose is we can have another sensor called the EM tracking system. It can provide you the 3D location, 3D pose of the sensor. And then you can put the sensor on the camera, and when it moves, you can get the point cloud in different coordinate frame, but you also have the global coordinate frame of the sensor from the EM machine. Then what you can do is you can use the pose to transform all the point cloud in local coordinate frame to a same coordinate frame and put the point cloud together to make a reconstruction. Right? But for this project, you need to get access to the sensor and also the EM system, which means you can't do it in a simulation. You cannot do it in the simulation. All right, so if you want to choose this project, which means you can't do it in the simulator, you have to do it with the real sensors. You need to do some experiments. All right, so if you feel difficult of doing that, don't choose that project. No, you can't. You can't. So everything. So I need to mention that for every real robot project, you can't take anything back to home. This is the rule. This is the rule for the Mechatronics Studio. So what if you choose a real robot project and you want to do on a real robot project, what they want to do is they will locate you a marker, a locker with the robot inside. And every time you have to, if you want to work on a real robot, it has to be inside the Mechatronics Studio. You can't bring it out. It has to be worked. It has to be worked in the Mechatronics Studio. And also, there's a limited number of students at a single time that which can allow in the Mechatronics Studio. So the Mechatronics Studio. So the manager in the Mechatronics Studio will give you a timeline about on what time you can go there and work on it. All right, so which means it's not allowed for you to bring anything out of the Mechatronics Studio. Everything needs to be worked inside it, and also there is a timetable. You can't go there. You can't go there anytime, but it is open 24/7. 24/7. So which means you can. They will locate you the time about when you can go there and work there, but you can't go at any time you want. All right, so I think that's clear, right? So if you have an Xbox Kinect, you can work on the project with the RGBD sensors. But the only thing is for this project, there is another sensor, EM sensor. That EM sensor, this is a very big machine. And that EM sensor is located in our lab in building 2. You can't bring it back to your home. There's another project about 3D RGBD camera visual surveying. If you have a RGBD camera, then you can choose that, use your own camera. That's totally fine. That's totally fine. But if you want to borrow something from the Mechatronics Studio, or if you need some other equipment not belong to you, then you can't bring it back to home. All right, I think that's clear, right? So again, for this for the real robot projects, if you can't, if you think that management you can't deal with that, then don't choose that, or you can choose that project with the simulator option. All right, so that is group project 5. And the next 2 projects about the turtleballs. And for turtleballs, you have 2 options as well. One is to work on the turtleball simulator. You can work everything on the simulator, or you can work on the real robots. And again, if you want to work on the real robots, it has to be in the Mechatronics Studio, and you can only come to there and work on that with arranged time. The manager will arrange the timetable for us. All right. So the first turtleball project is the turtleball following a straight line by observing a square. What I mean is, suppose on the wall there is a square or some markers on it, and use some kind of like sensors. You can observe the markers or the square on the wall. Then you can control the turtleball to have a path which is perpendicular to that square, or perpendicular to a designed line which is perpendicular to the wall with the markers, something like this. But I do have some other objects. I do have some other projects by the students. They have some different solutions. For example, I do have some projects that students have different markers on the ground and with QR code on each of them. Then they will control the robot for a designed direction or design a path or something. So I'm quite open on that. But the thing is, I need you for this project. I need you to provide some autonomous control of the Turtlebot by observing some markers or some landmarks or something. All right. So this is the first Turtlebot project, and the second Turtlebot project is Turtlebots following each other. It is quite similar to what we have in the Fetch Robot project. So in this project, you will have two Turtlebots. The first Turtlebot is the leader, and you don't have to control on the leader. You can control it by a joystick or something, by a remote control or something. You don't have to make autonomous control on the leader of the robot. But for the follower, you have to write your algorithms to let the follower to follow the leader Turtlebot, and that is autonomous. And you can use any of the sensor you want. There's the RGBD sensor on the Turtlebot, and there's also a rotating laser radar on the Turtlebot. So you can use any of the information or any of the sensor on the Turtlebot. But the aim or the task of this project is you have two Turtlebots. The first one is the leader. You have to control on that. You just need to like manually control the first one, the leader. But for the follower, it can automatically follow the leader. All right, so that's the Turtlebot. That's the second Turtlebot project. And after that, there's a video serving project. This video serving project is suppose you have a handheld RGB camera. It's not depth camera, RGB camera. And then suppose you have a checkboard on the screen or on the wall. Then you need to do a video serving. You can do a video serving. Every time you can calculate the control of the handheld camera, then you can display the control, and you can follow in that control to make your camera move to designed location of it. If you don't know what is a video serving, so go to the video serving section of this subject and have a look on the video and also the lecture note. All right, so that's the video serving of the handheld camera. And the next one is the video serving with an RGBD camera. So it's exactly the same about the video serving, but you can choose your camera as an RGBD camera instead of the normal camera. All right. So in this case, if you have an RGBD camera by yourself, then you can debug everything at home, right? But if you want to borrow an RGBD camera from Mechatronics Studio, for everything you need to test in the Mechatronics Studio. You can't bring the sensors back to home. All right, so that's the project 9. And project 10 is a little bit complicated. It's 3D control and path planning for the surgical robotics catheter in the aorta. So if you remember, in the first lecture, I explained it to you about the project I did in the vessel in the aorta, right? So there is a robot inside the vessel. Then how to control the catheter robot in the vessel is we use the ultrasound. If you remember, we use the ultrasound, which can get the cross section of the vessel wall. Then you can use the ultrasound to control the catheter robot inside the vessel. And this is done purely in simulation, or you can done it by yourself offline. We can't do it online at the moment because it requires a lot of setups and it's quite hard to access everything at the moment. So it's purely offline on the simulation. I can provide you some of the data, and you can get access to the data and design your control method on that. But what I want to say is Project 10 is a bit difficult. I have some groups which choose the Project 10, but they've never done a very good job on that. So think carefully about choosing this project. All right, so that's all the projects, and hopefully you have a better feeling on this. Let me double check if I have some videos on that. I don't think I have videos on that. That's the problem. No, I don't have some videos. So I think I've explained to you about the deliverables and also each of the project. I think you have a brief understanding about each of the project. Think about it carefully, and your next job is to form your group with 3 students and choose the projects from the list. Or if you want, you can propose your own project, but you need to discuss with me. All right, and before Sunday 6 p.m., please post your forming of the group together with the projects you choose onto the ETS online discussion board. And then on Monday, I can locate you the project and you can work on that. All right, so is there any questions on what we have now? All right, so if everything's good, I will, oh, sorry, I think I have a question. I do have an example. I have a lot of reports, but I can't give you an example on that. I think I've explained clearly about what you need to write in each individual deliverables. But in the final report, if you want a detailed explanation about what's the structure of that and what you want to write, I can explain it to you a little bit later. But the most important thing for me, I think, is choose a proper project that you want to do, and try to work on the project well and try to finish the task in the project. And then after that, you'll find you really enjoy working on this kind of projects because you're working on real things, and at last you can demo it to the other side. And also from my previous experiences is that the students are really enjoying working on project with real robots. It's full of fun, but there are some trade-off of it. For example, it requires you to come to the Tron studio to work on that, and there's some kind of like risk about safety, right? And also working on real robots is a bit harder than working on the simulation. You will find it out. So that is an amazing thing in robotics or mechatronics. So doing things in simulation is totally different from doing things in real robots. That's the thing we always have. So you will find working on simulation and working on real robots, they're totally different. And there are good things and bad things. So you need to evaluate by yourself and choose the one that you want to do. For example, if you want to choose it only working on real simulator, that's totally fine. There's no marking difference comparing to the real robot. But by working real robots, you need more efforts on that, but you will learn more from it. Right? This is something you need to think about and you need to balance. Also, this kind of thing you need to discuss with your team members after you forming a team. All right, so if everything's good, and I will stop the lecture and I will move